Hello everyone, welcome to the class. Let me just check if I'm online. Good morning Akshay and welcome back. In today's class we are going to see the lesson 2 of your kinematics. So in this class we will learn more about velocities, again about speed, and then we will try and go into acceleration as well. All right, and if there's time we will derive the equations of motion. So that's what the topic we're going to cover in today's class. Once again, I'm a physics educator at Unacademy. I'm basically taking you class 11 and 12 physics, and my name is Mohana, and this is my Telegram channel. So any updates I would be sharing here, so you can join me on my Telegram channel. And this Telegram is common for all Unacademy ISE and ICSE boards, so you can follow this Telegram channel as well. Okay, and just like how we have classes on the YouTube channel, we have special classes. These special classes are absolutely free, but these classes happen on the Unacademy platform, so you can learn from any of your favorite educators for free. Okay, and we have an interesting feature that is basically the pools, so you can interact right with the educators via this pool when classes are going on, right? So, and also, since these are live classes, any doubts are there, you can actually ask the educators and get your doubts cleared as well. Okay, and the links for the upcoming, for the next month, what are the special classes, I will share it soon. And if in case you're interested in the plus subscription, right, so plus subscription has certain features. One is you can learn from the comfort of your home, and at the same time you have unlimited access to all the courses, right? So if you're taking a plus subscription, you'll be taking the course for physics, maths and biology as well, right, and chemistry as well. So you'll have unlimited access to all of the courses, and then all the educators at Unacademy are good, so you'll be learning from top educators. And we also have a doubt clearing session. That is, if in case the session starts, if in case a batch starts today, fourth class is actually a doubt clearing session, right? Every fourth session is a doubt clearing session. Whatever topics you have learned in the first 3 class, any doubts you have on them, you can actually ask them during the doubt clearing sessions. Okay, also we also have a live test series happening every weekend. Okay, so you can check that out as well. And after the live sessions are over, there will be an analysis session for the same. In case if you have any doubts with the questions, or in case you've got if you made any mistakes in the question, you will be able to correct and learn them then and there. And in case if you want to know how to solve the question better, you can learn from the educators then and there itself. And at the same time, we are coming up with different batches and courses, right? More courses for class 11, so do check them out. And the price range, if you look at, right, as you take for more number of months rather than 1 year or 9 months, if you're taking up for more number of months, let's say like for 2 years, longer duration, then the price the longer duration you take, the price per month is actually less, right? And on top of that, if you're using my educator code MTIS10, you'll be getting a 10% discount on the same as well. Whatever duration you're taking, or the course that you're taking, if you're using my code, you'll get a 10% discount. Now, Unacademy is also having the UNSAT, that is the Unacademy National Scholarship Admission Test. Now, this is an offline test, right? This is basically happens in the offline centers, but it will be a computer-based test. In case if you're planning to write your IIT JEE and NEET in the 2023 or the coming years, right? And if you want to look in for different coaching centers, then this would be the best option for you right now, because they are giving a scholarship. So you can just try taking the admission test. So here in case IIT JEE, other than IIT JEE and NEET, we also have, in case you're in class 9 and 10, and if you want to take foundational courses as well, you can attend this admission test. So this test is happening around 40 cities, and the last date for registration is June 2nd. So the registration fees is 199 rupees, and if you're using my code MTIS10, you'll get a 10% discount on the same. Okay, then this is happening. This test is happening between 4th and 5th. The top 40 rankers will get a chance to win an iPhone. All test takers get an Unacademy t-shirt. At the same time, in case if depending on how much percentage you've got, you can get up to 90% scholarship as well. Okay, if you come in the top rankings, you can get up to 90% scholarship for taking the IIT JEE NEET or foundation courses with Unacademy. So this is true for Unacademy offline centers as well as the Plus subscription, the online classes that you're taking. Alright, and we started last class with motion in a straight line. So before that we began with an introduction for what is mechanics. Okay, whenever you're studying about an object in rest or in motion around us, that's basically comes under mechanics, which is a branch of physics. Now this mechanics is again divided into three, yes Akshay, is divided into three branches. One is statics, one next is kinematics, and then dynamics. Okay, so statics is very simple. If you're studying about an object at rest, okay, or in equilibrium, okay, though there are several forces acting on them, if they are still at rest, then we say, then we study those objects under statics, right? So measurement of time is not essential over here. That is right, Akshay. We studied statics, dynamics, and kinematics is right. Now kinematics is basically the study of motion of an object without considering the cause. The object is in motion. We are not bothered about what caused the object to be in motion, right? We are just dealing with the study of object in motion. Okay, that's kinematics. Measurement of time becomes very essential over here. Okay, then dynamics, very simple. We're going to deal with the study of motion of object, taking into consideration the cause for their motion. Okay, so in dynamics we are dealing basically with forces. All right, dynamics, you're always dealing with forces, which is basically the third unit in your class 11. Next comes the rest and motion. What is rest and motion, right? Rest is very simple. Whenever we are talking about rest or motion, we are talking about from a frame of reference. Okay. Now, in case you are standing on a platform, a train is moving by. With your point of reference, you are stationary, but the train is moving. Okay. But for a person who is sitting inside the train, okay, they are in rest, but everything outside them moves. Okay, so whenever we are talking about rest or motion, we are talking, these are relative terms. We are talking them with respect to some other object. Okay, an object is said to be at rest if it doesn't change its position. If it is not changing its position with respect to its surroundings, it's said to be at rest. For example, what would be an example of rest? An object is said to be at rest if it does not change its position with respect to its surrounding with the passage of time. So what would be an example of rest? Right, as Akshay say, a book that is lying on a table, and any object that's on your table, that's completely at rest, right? With respect to other objects that's moving around, this particular book, or right now my laptop, that is basically stable, which is basically at rest on my table. Okay, so all of that are basically object at rest. When you say an object is in motion, this is set. It is basically, it changes its position with respect to its surrounding with the passage of time. Okay, then we say an object is in motion. Okay, then so an object in motion, this basically you can say a train moving on a rail, a bird flying, right? With respect to us, the object is, with respect to us, if you're seeing a bird that is flying, it's actually in motion. All right, so this is about rest and motion. Right, this is about rest and motion. Next comes the concept of point mass. Whenever you take an object, if their mass is, if they are said point, they are called as point object or point mass, when the change in its position is very large when compared to their own size. One of the example is Earth going around the sun, right? Now, if you look at the Earth, right, at one point it is over here. After a few months, you can say, after 6 months it's over here. So this is the path, this is the change in its path, right? But what is the size when compared to the size of the object? The change in its position over 6 months or whatever duration is, that is actually large when the Earth is going around the Sun. At this case, you can call the Earth as a point mass. Alright, so this far we have seen as well. And we also saw motion in 1, 2 and 3 dimensions, right? Motion of 1 dimension, that's right Akshay. And motion in 1 dimension is very simple. If of all your 3 coordinate axes, only 1 is taken into consideration, that's motion, or then that particular, then if if only 1 coordinate axis is need to specify the position of the object with time. Okay, the position of the objects changes with time. For example, if a car is going on a straight line, okay, if the car is going very straight, right, you just need only one axis is more than enough to give this talk about the change in its motion. Okay, now when two-dimensional an object of motion is said to be two-dimensional when if 2 of the coordinate axes specify the position of the object. Okay, so you have an object, right? So for example, the Earth going around the Sun, right? That's a 2-dimension. And if there's any insect or any thing that is going in a zigzag path, right, that's 2-dimension. So when you talk about when you're talking about 1 dimension, you're talking about a straight line path. Okay, so straight line, any motion that is going straight. Okay, right, if a car is going straight or any object that is going in a straight line path, what do we call that particular motion as? When we call that particular motion as, so we say it's in a linear motion or rectilinear motion. Okay, then in case of a 2-dimension object, now if you're using 2 axes, right, you can use 2 axes to specify its dimension. Now what comes into a plane, now what comes into the picture is basically a plane. Now we are talking about, when it's 2-dimension, we are talking about a plane, because we are talking about 2 coordinate axes, so we are talking about motion that is happening in a plane. Okay, if the object is changing, the position of the object changes with time, but with respect to 2 axis coordinate axis means, then we say it is a 2-dimensional. Okay, 3-dimensional, very simple. If let's say an insect is going zigzag, okay, and then it has wings and suddenly starts flying, right, then you make use of a 3rd dimension as well, right, because why? Height is coming into consideration. Then the motion of an object is said to be 3-dimensional if all 3 coordinates specify the position of the object changes with time. Okay, then here flight, usually if you see a bird in flight, or when you are actually seeing any planes that are going in the sky, right, all of these are example of 3-dimensional motion. Because if you look at a bird, somewhere at one point it will be in one height, after sometimes it's somewhere else, but rather than its xy coordinates, there is a height coordinate that is involved as well. Okay, this is basically motion in 3 dimension. From here, let's see the difference between a distance or path, right? So the distance, or we call it as path length, is nothing but the length of the actual path traveled by the body between its initial and final position. Okay, now in case, yesterday we saw an example of you being in school, right? And from home you're going to your school, right? From home you're going to school, but you from your home you're going to your friend's house, right? Friend's house. From there you guys go to a juice shop, right? And then you guys then with all your friends you're going to the school. Now this entire path that you have taken from your home to the friend's house to the juice shop then into the school is basically called as your path length. That's the path covered. So this is your initial position. Initial position was your house and the final position was the school. Okay. Now here the distance is nothing but from your house to the school. Okay, that's the length of the actual path transferred by the body between its initial and final position. Okay. Now, what is distance? Is distance a scalar? You guys answered this yesterday. Once again, is distance a scalar or vector quantity? Is distance a scalar or vector quantity? It's a scalar quantity. That's right, Akshay. It's the scalar quantity. and distance covered can be positive or 0 only. What does it mean? Distance covered from 0. In this case over here, the distance covered is basically 0. It's gone from here to here to here, right? So in this case, the distance covered is a positive value, right? Initially you were at home and you've traveled around 5 kilometers. So distance covered can be positive. What do you mean by distance covered being 0? When will your distance covered be 0? When will this distance covered be 0? The distance covered would be 0 if in case you're staying at home. Whenever the object is at rest, right? Then we can say the distance covered is basically 0. Okay. Now, from here we will learn about displacement as well, right? And the SI unit of distance is actually meters. SI unit of distance, because it is measuring the length, it is meter. Okay. Now, displacement, that's right, Akshay. Object at rest, that is distance. Displacement of an object is what? The change in its position of an object in a fixed direction, right? Now, displacement, when we are talking about displacement, we are talking about a vector quantity because direction is also involved. Now, we have seen this in the last class. Displacement, right? Displacement is the shortest position. From your school to home if you're going. Directly from school to home if you're going. Not through your friend's place and the bakery, but directly from school to home if you're going. Then this, from initial to final position, right? Initial, if this is your initial position. Final, what is your final position? This basically gives you your displacement. And since here it's a vector quantity, not only it has magnitude, it also has a particular direction. You're going from your home to school, right? If you're going from your home to your school, then basically there is a question we are asking, which direction? Are you going north? Are you going northeast? Are you going south? Okay, that comes into picture. Now displacement, sum of the property, it can be a positive value, it can be a negative value, or it can be 0. What does it mean a displacement is 0? If this is your house and this is your school, right? You're going to your school and from there you're coming back home. Your initial position is at home, your final position is at your home as well. Now displacement becomes 0. Okay. Yes, Akshay, we saw certain examples of that in the last class for displacement as well, right? Right. And then we started with the velocity, right? What is velocity? Before velocity, let's actually look at speed actually. We can look at speed and velocity together. What is speed? Okay, the distance traveled. Okay, speed is nothing but the distance traveled in a unit interval of time is called the speed of the object, right? So speed is given by what? Speed is given by distance by time travel. So distance, so in this case speed will be the rate of change of position of an object. That's also right, right? Time taken, right? Here speed is basically to represent speed we use the symbol v again. Speed is basically a scalar quantity. Okay, why is it a scalar quantity? Because the distance that we are taking over here, this distance is basically the total path length covered. That is a scalar quantity. We are not worried about the direction. Okay, so speed is basically a scalar quantity, and this in this case the dimension, the unit SI unit is basically meter, right? SI unit is meter. In this case it will be meter per second. SI unit is meter per second. So the dimensional formula of speed is meter is given in terms of length, right? L, and seconds is time, so T inverse 1. That's the dimensional formula. Okay, now there are various types of speeds. Okay, one is basically uh, called as your uniform speed. Okay, in uniform speed, an object is covering equal distance in equal intervals of time. Okay, now when you're going, right, let's say if you're going, okay, from your home to your friend's place, okay, you're covering 2 meters, right, in, let's say you're covering 2 meters in around 10 minutes. Okay, now again another 2 meters in another 10 minutes. Again another 10 minutes is a huge time to cover 2 meters, so let's go with 1 minute. Okay, 1 minute. Likewise, from your home to your friend's house, the distance you're covering with time is very uniform. Okay, so the object is covering equal distance, okay, equal distances in equal intervals of time. Then we say it's a uniform speed. Then the speed is basically, we say it is uniform. Okay, other than uniform speed, we also have a variable speed. Right? In case of a variable speed, what will happen is the object will cover different distances in equal interval of time. Okay, distance covered, right? Distance covered is different. Okay, but in equal intervals of time. What happens over here in this case? Same case for example, you're going from your friend's place to your friend's place, right? But you're going very slowly, right? So for a particular distance, for a particular time of 1 minute, you're only covering 1 meter. Okay, then for a particular point of 1 minute, you're covering 1.5 meters. Then again for another 1 minute, you're covering 2 meters. Okay, right? Or in this case, you're slowly increasing your speed. Or, right, you walk for some times, you see something, you stop, and then you do some, then you start moving around. Okay, when for a given time, for a given point, you can actually go 5.5 meters, then you could have gone 2 meters, and then you could have gone 1 meters. Okay, the distance, the time that is taken to cover these distances are same, but in a given interval, the distance covered is different. Then it's a variable speed. Okay, clear till now? Okay, can I go ahead? Okay, now right. Now, other than uniform speed and variable speed, we also have average speed. What do you think will be average speed? Let's say going from one location to another, you had taken, okay, going from one location to another, you had taken 5 meters, you've covered 5 meters in 2 minutes. Okay, then average speed is always given by, okay, total distance traveled by total time. Total distance traveled by total time. Here, what is the total distance traveled? 5 meters. What is the total time? 2 minutes. Okay, minutes in times of seconds. So this will become 5 minutes by 2 into 60. 1 minute has 60 seconds, right? So from here you can get your average speed. Your average speed in this case will be 5 by 120 meter per second. So whenever you're talking about average speed, you're talking about the total distance traveled from the initial to the final. The total distance traveled by time will give you the average speed. Okay. Other than this, there is a particular speed called as instantaneous speed. What will be instantaneous speed? If the speed of the object is continuously changing with time, right? With time, the speed is continuously changing, okay? Then that particular speed is called instantaneous speed, okay? Every path along this path, let's say you're driving from your home to a mall, okay? You're going in a car. The speedometer in your car will basically show instantaneous speed. At every point, there is a change in speed, right? At every single location, when you're going from home to the mall, at every single position, there was a change in speed, right? That speed is basically called as your instantaneous speed. Okay, the speedometers that the pole is basically used to check what is the speed of a car, right? Let's say the car is going from here to here, right? Initial to final position. Let's say there is a police vehicle here. If they are measuring the speed in as the car is crossing with this speed, they are measuring what is the vehicle speed. Then the speed that is registered on the speedometer of the police the police has is basically what is the speed at this particular location. It's saying it is not talking about the average. It's not talking about the average speed. It's not talking about the average variable speed or the uniform speed. Okay, all it is talking about is basically at that point. At that point, what is the speed? Okay, the speedometer in your car always indicates a instantaneous speed. So here we have seen what is with respect to with respect to speed, right? We have seen what is uniform speed, right? Object covering equal distance in equal intervals of time. Variable speed, object covering different distances but in equal intervals of time. Then you have average speed. Average speed talks about the total length, right? The total distance or the total path length the object has traveled or covered for by the total time taken. Okay, and then you have instantaneous speed. Okay, in any, let's say if this is the path that an object, okay, if an object is over here and if a car, okay, is going on a mountain, okay, at every point, what is the speed? If you take a very small time and see what is the speed here, what is the speed here, what is the speed here, what is the speed here along its path, if you're seeing what is the speed at each instances, then basically that becomes your instantaneous speed. Any doubts till now? No doubts. Alright, great. Similar to this, we also have velocity, right? What is velocity? Velocity is nothing but the displacement. We are talking about now a vector. The displacement of an object in unit interval of time, right? Unit interval of time. This is basically called velocity. So velocity is basically given by displacement by time, that is right. Equal displacement in equal intervals of time. Actually, what is that called as? If there's equal displacement in equal intervals of time, what type of velocity would that be? This is displacement by time taken, right? Displacement by the time taken by the object. Now again, the unit is basically meters per second. Unit is meter per second. This has a dimension formula of uniform. That's right, Akshay. L G inverse 1. Okay. Now, right. Again, velocity also you can tell in terms of uniform velocity. The in this case we're talking about displacement, right? So in case of velocities also you can talk about it in terms of uniform velocity, right? We spoken about speed, so velocities can be uniform velocity, right? Velocities, uniform velocity. So, and you can say an object is a uniform velocity if it covers equal displacement in equal intervals of time. Okay, so it is going, velocity is somewhere, what to say, like, okay, let's say you're in one city. Let's say you're in one city. Okay, you want to go to another city. The route can be, the actual path can be how much ever it is. But this is the displacement, right? So when you're talking about velocity, we are talking about, in case of uniform velocity, if the object is covering equal distance in equal intervals of time. Okay, now the shortest distance in this case, if you're going in a straight line path from home to school, right? If you're covering equal distance in equal intervals of time, then we, as you guys have said, it's basically uniform velocity. Okay, what will be a variable velocity? What will be your variable velocity? Velocity being a vector quantity, right? Velocity being a vector quantity. The change in the position, right? If it is covering the displacement, we say this is equal, right? This is displacement is 1 meter in 0.5 seconds, 0.5 seconds. 1 meter. Sorry. Let's say in 1 meter in 1 meter, let's say you're covering 1 meter in 2 seconds. Okay, now same from home to school. Okay, if the length, right, if there is unequal distances for every 2 seconds, let's say for every 2 seconds, this is the example that I'm just taking it as 2 seconds. Okay, obviously you can't, unless and until you're staying right next to your school, you can't reach it in 6 seconds, but I'm just giving for an example. So in this case, let's say this is, here you're going in 0.5 meters, then you go for 2 meters, right? And then you are basically covering just 0.7 meters. Unequal distances and equal intervals of time is basically your variable, right? Let's make this minutes again. Okay, is basically your a variable speed, but variable velocity. But is this the only thing that is called as variable velocity? Velocity is a vector quantity, so it has both magnitude and direction. Okay, magnitude is changing, equal distance at equal intervals, at equal distance, unequal, it's covering, and equal distance, it's covering for a given time interval, it's covering unequal distances, right? But in this case, this is basically, we're talking about magnitude. What else can change for us to get a variable velocity? Okay, in this case, for every time, right, if every interval that we are taking, speed is changing, right, velocity is changing, right? 0.5 meters by 2 minutes, this is a different velocity. 2 meters by 2 meters by 2 minutes, this is a different velocity, right? 0.7 meters by 2 minutes, this is a different velocity, right? The velocity in all these cases changes. Okay, so variable velocity is when the velocity, okay, object is said to have a variable velocity if the velocity for a particular time changes. For a given interval of time, velocity changes. What else can change? Other than velocity, direction also can change, right? Because it's the magnitude of the velocity changes for a particular time. Magnitude of velocity, okay? So what is the magnitude of the velocity can change. Other than that, what can say? Direction can also change. All right. Okay. Then what else can say? Then what else can change? Other than direction, let's just take off a road, okay? You're going this way and you have to change your position, take a U-turn and then go straight again. Okay? Direction can also change. Right? Then both can also change. Both the magnitude of the velocity and the direction. Both can also change. All of these will result in a variable velocity. All of this will give you a variable velocity. Okay, with respect to velocity, variable velocity, we are talking, this is a scalar, this is a vector quantity, so magnitude can change, direction can change, or both can change. Okay, then you have average velocity. Average velocity is very, very simple, right? Okay, what is average velocity, right? If the average velocity is basically defined as what? It's total, right? Total displacement, average velocity. Average velocity is very simple. What is the total displacement per time, total time. Okay, so whatever from your home to school, right? What is the total velocity, right? What is the total displacement, right? To the total time taken. Displacement can be 5 meters. Time taken can be around 10 minutes, right? Then if you're going by car, right? So this displacement, let's say, is around 50 meters. 50 meters is too high. Again, 50 meters is half a kilometer, right? Not even half a kilometer. So if in case you're going in this speed, this is the velocity, then total displacement by total time. That's your average velocity. Okay. Again, you have something called as your instantaneous velocity, right? In the entire path that you're taking, okay, at a particular point or a particular instant, okay, of its path, what is its velocity, right? Let's say you're going from your home to your school in a car, and in the what is showing in your in the car, again, if in this case, if you take a particular time, at the particular time you're looking at the direction as well as the magnitude. What is my velocity at this particular instant of time? On the entire length at the particular time, if you're taking, that's instantaneous velocity. Okay. Clear? Any doubts till now? No doubts. Okay. Let's look at some of the graphs, right? Let's look at a graph. Let's say, okay, we are drawing a graph between, right now we are doing speed and velocity, right? Let's look at a graph between time. Let's say, look at a time. Let's say this is the time taken, okay? And let's say this is the displacement. Okay, position time graph. Okay, let this be around 0 minutes. Let this be 1. Let's say this is 1 second, 2 seconds, 3 seconds, right? 4 seconds, and so on. Right. What gives the what gives the velocity here, Akshay? Right. Let the time goes by around 20 meters you're covering, 30 meters you're covering, right? 40 meters, right? And from there to 20 meters, 40 meters, let's say the distance is 20 meters, 60 to 80 meters. Okay, in the entire time, for every seconds they're doing, time is given in terms of second, displacement here is given as meter. Okay, so for every second, this is too high. So in 1 second you cannot cross 20 meters. But let's say, for example, let's say maybe 2 meters possible, but not 20 meters in 1 second, right? In 1 second you cannot cross 20 meters. But let's say from here, for every minute there's a 20 meter you're covering for every minute, right? Then in this case you will get a straight line graph. Okay, what type of displacement would this be? What will we get? Okay, here this is a time displacement graph. The slope at any point, if you're measuring the slope, right? If you measure the slope at any point, right? Let's say over here, if you're taking, this is 1 second, for that what you're getting. So this is T1 and this will be around displacement, right? So let's take this value as S1. Okay, somewhere over here we can take, this will be T2 and this value will be S2, right? So now this difference between them, this difference gives you T2 minus T1, right? And this difference, right, this difference over here gives you S2 minus S1. So T2 minus T1, we can say it is delta T, change in time, S2 minus S1, change in position, delta S. Okay, now the slope of the graph. Okay, so whenever you're taking the slope of any graph, right, what is the slope in this case? How much, how much angle it is making over here, right? The slope of this graph will basically give us, from here we can actually determine what is velocity, right? What are the two quantities we need over here? One we need is basically this angle, and we need this side, and we need this side. What gives us these two sides? That basically what we give, which angle will give us these two sides, right? Because this is more like this particular part is more like a right angle triangle. Okay, this is delta T and this is delta S. So this angle you're measuring will become so this is tan theta. Tan theta will give us your perpendicular to base, right? This perpendicular to base is delta T, delta S by delta T. Delta S by delta T is nothing but S2 minus S1 by T2 minus T1. So this is nothing but the displacement, how much change in displacement, right? And this is by the time interval, right? Time taken or the time interval. So this is nothing but your velocity. Okay, so the slope of your displacement time graph gives you velocity. So what will the slope, right? If you have a slope, if you have a graph, okay, and you're getting a straight line, this is basically time and this is basically distance. The slope of this graph will give you what? Right, the slope of this graph, right? This will give you speed. Okay, now let's just see some more. Okay, one. Okay, let's say you have two objects. Okay, let's consider, let's say there are two graphs, right? This side is basically time in seconds. Let's say this is going as 0, 1 second, 2 seconds, 3 seconds, and 4 seconds. For example, we are taking over here, right? And let's say this displacement is around 10, 20, 30, and 40, right? It goes like this, and this is displacement. Okay, this is x-axis, and your y-axis is basically displacement. Okay, one object travels in this path. Let's say this is B. Another one has this straight line. Let's say this is E. Okay, right. Now, if what happens? What is the difference between the line A and line B? What is the difference between the line A and line B? Speed is slope. What can you tell about the slope? Which of these two lines, which has a greater slope? Of these two lines A and B, which has a greater slope? Slope A, right, correct Akshay. Slope this A has more slope. So if the slope is more, right, if the slope increases, if there's an increase, if the slope is more, then that object has more velocity, right? So that then now same point. What about this graph? What does this graph represent? Would it be uniform? Try to think of as the time is passing by, right? As the time is passing by, what is happening to the displacement? What is happening to the distance or the displacement, that is the length that it's covering? Would it really be a uniform velocity? Think about this. Time is progressing by, but the displacement, or what in case of displacement, here we're talking about the change in position of the object is constant. Time is progressing by, but the change in position of the object is constant. What does this graph represent? Let me just say, what is the slope in this graph? Can you take a slope for this graph? What will be the slope for this graph? The slope for this graph. Right. If it's a horizontal line, will it have a slope? There's no slope over here. This is 0, right? There's no slope. Then your change in displacement, if you see look at the displacement, it's not getting displaced at all, right? Because the velocity is given by displacement by time, right? You can get this only when if there is a slope, like in the previous class, right? Like in the previous case, we can actually take a particular section and we can say, okay, this is your displacement. How much? First, it was initially the position of the object was at 20 meters. Now, after sometimes it's at 40 meters. So, okay. So then we can say this particular object has gotten displaced by 20 meters. And what is the time taken by it? Then you can say somewhere around 1.5 seconds to 3 seconds. There is a displacement. Right? Then in this case, the displacement, there is a displacement with time, then you can say there is velocity. But in this case over here, there is no slope. Slope is 0, which means there is no displacement. If there is no displacement, what is happening to the object? What can you say about an object? As the time is progressing, there is no change in its position with time. Then what is the object at? What is the state of the object at? It will not move, correct? The object is not moving. So in this case, the velocity is basically 0. So the object is not moving at all. So this is when an object is at rest. This graph is when an object is at rest. That's right, Akshay. Ankit Singh, that's right, the object is at rest. Okay, this is a graph you get when your object is at rest. But when do you say it is uniform? When do you say the object has a uniform velocity? Right? Let's say you're going in a car, and for every seconds the car is basically taking around. Let me just check this. Okay, every 1 second the car is covering 10 meters. Okay, second another 10 meters, second 3 another 10 meters, second 4 another 10 meters. Then what you get? You get a straight line. Right? Yes, Ankit Singh. Right? So then you get a straight line. Now this is at every instant if you take, see, if every instant you take, right, there is a 10 minutes. In this case, you get this is 10 meter displacement for 1 second. Every instant that you take, 10 meter displacement for 1 second. This also 10 meter displacement for 1 second. Right? Then what do we say? In this case, it is uniform velocity. Okay, 10 minutes gap, that is right, for every second. Now, right, now, what will be a variable velocity? What will be the graph of a variable velocity? Right? So let's say the first minute it covers 20 seconds, right? Second minute it covers just 10 meters. Right? Third minute again, let's say it covers somewhere around another 10 meters. Right? Then this would be a variable graph, and the slope that you're taking at any point might change. Okay, and right, but you're still getting a straight line graph in this case, right? So variable graphs, variable position, velocity, when the velocity is varying, right, then in this case you can get an object like, let's say, first time it is covering this distance, it might cover this distance, then it may not cover, and then it can just drop down. Okay, if the velocity of the object, in case in this case what is happening is, for every time the velocity associated with it changes, right? In this case the velocity associated with it is changing. At one particular point you can say the object is less, and then it is actually decreasing. Okay, so you can actually see, if in case if you're going in a car, right, if you're going in a car and you're going in a traffic in a place where there's traffic, let's say the first few minutes that you're trying to go slow, then you try to speed up, then because of the traffic, if you're stopping somewhere, that is there. But when you're accelerating, right, to stop, that can be given by the distance you're covering. When it's coming down, right, in this downward slope, you can say you're coming towards a stop. That is when you're decelerating, right? When your displacement that you're covering is reducing. You're in a traffic jam, the distance you're taking, right? This displacement covered per time reduces. That's negative displacement. That will give you a deceleration. Okay, and if the object is varying continuously, if the velocity is varying continuously, okay, then the graph you will be getting would be would actually vary. Would go something like this. If the speed is changing, how much for a given time, if the speed is changing, then your line will be something like this. We'll see more about this in the upcoming classes as well. Okay, we will learn more about the graphs, right? The speed graph and the velocity graph, position graph. Okay, all of these we will see in the upcoming classes. And once again, today evening also, right? Just like how we learned about velocity, there is acceleration is nothing but rate of change of when there is a change in velocity of an object with the time, we call acceleration. In acceleration also we have uniform acceleration, variable acceleration, average acceleration, and instantaneous acceleration. We will see all of those in the upcoming classes. Okay, and once again we are again coming up with different batches and courses. So for class 11 we have the batch starting at 8th June only. The mode of delivery will be in English. And also, if you're in class 11, right, if you're taking a class 11 subscription, you're getting a class 12 subscription. That 1 year of class 12 subscription is absolutely free. So there'll be a number in the description box. If you're planning to take subscription, right, you can call them. They'll tell you how to take it, right? Or you can actually just click on the link and go and take the subscription. There are 2 links that are given as well. And if you click on the link, it will take me to all of my videos that are free videos that are there in the in the Unacademy website itself. Those few classes are special classes where it's absolutely free. You can go and watch the content as well, right? Then again, for in this batch, right, the focus of this batch is going to be your completing your term 1 syllabus, that is the first 5 units, right? And I'll be taking physics, and every class between Tuesday, Thursday, Saturday between 5:15 to 6:15. Jyoti ma'am will take math, Manisha ma'am will take chemistry, and Lakshay sir will take biology. Okay, so do join the course. In case if you're planning to take, it might be the right time to take, because if you take a class 11 subscription, class 12 subscription is absolutely free. So you're just paying for 1 year, and you can use my code. You can use my code MTIS10 to avail a 10% discount on the same as well. Okay, and also we have the UNSAT, that is the Unacademy National Scholarship Admission Test. So this is an offline test. This is going to happen in the offline centers, right, of Unacademy, and it will be a computer-based test. In case if you're planning to attempt your IIT JEE and NEET exam, you're trying to attend it the upcoming year, right? This might be a very good opportunity to take the scholarship test, because for taking these courses, IIT JEE and NEET courses with Unacademy, you might be getting, if you come in the top ranks, you might be getting a scholarship as well. And in class 9 and 10, if you're in class 9 and 10 interested to take foundation courses, you can attend as well. The test takers will take it an Unacademy t-shirt. The top 40 ranks you can have a chance of winning an iPhone, and you can get scholarship up to 90%. Okay, so this scholarship is there even if you're taking a class from taking the class from the Unacademy centers, or even if you're taking an online subscription. The last day to register is June 2nd, right? And the test is on 4th to 5th. The registration fees is around 199 rupees. You can again use my code MTIS10 to avail a 20% discount. Okay, then we are introducing the community feature. So here you will never miss any update from your favorite educators. So you can share your feedback also directly with your educators, right? My Unacademy community link is given over here. You can check out this community link, because there will be few pool type questions asked, MCQs asked. You can try attempting them. Okay, and also in case if you're seeing any inappropriate content in any of the videos, and if you're reporting the same, right, you can claim a prize, and click on the bell icon to subscribe to the channel so you know when the upcoming classes are, and like and share the videos. Alright, thank you, and I'll see you in the next class. And Akshay, your example of at unequal distances or unequal intervals of time, at equal intervals of time actually. Akshay, car going on a hill, that is right. That is a good example. And I'll see you guys in the next class. And I think we have a class today at 2:30. That is basically for measurement. Right, this is for kinematic class. At 2:30 we will be discussing about measurement. Alright, okay guys, see you in the other classes. Thank you for taking the course.